and welcome to the Microchip Is podcast. Join your host, Mike Maynard, as he learns about the technologies, products, and people that make Microchip Technology what it is today.
Welcome to the Microchip Is podcast. Today, I'm finding out that Microchip is battery management. My guest today is Iman Chalabi. Iman is the Senior Product Marketing Engineer at Microchip. Welcome to the podcast, Iman.
Thank you, Mike. My name is Iman Chalabi, and I'm Senior Product Marketing for Analog BU. I'm responsible for defining, developing, launching new product lines, especially mixed signal product lines such as analog digital converter. Also, in my role, I often collaborate with other business units and application engineers to create reference design and application notes or technology demonstrator that is using our product. And one of these key applications that we've been working on recently has been battery management system, or BMS, which we hopefully are going to talk more about in this podcast.
Yeah, I'm looking forward to it, Iman. It's going to be great. I mean, let's start talking about what these systems need to do. So there's obviously a lot of equipment that's battery powered, but what does the BMS, the battery management system, actually do?
So the battery management system in a nutshell is an electronic system that manages charging and discharging of rechargeable batteries. And it does it by monitoring key parameters such as voltage that is across the battery pack or current that's going in and out of the battery, and also battery temperature and a lot of other parameters that are really important for determining the battery health. We obviously have seen a lot of videos online showing battery incidents such as cell phones, tablets, scooters catching fires and exploding. These events really kind of show how dangerous battery failures are. So all of these kind of show how important are the battery management system to make sure these devices operate in a safe and reliable fashion.
I mean, that's obviously really important. You've mentioned a couple of applications there, from like phones through to e-scooters. I mean, can you talk a little bit about the range of applications that use battery management systems?
Yeah, I mean, battery management system are crucial basically for any type of applications that have batteries. From a complex high voltage application that require hundreds of cells of batteries, such as electric vehicle and energy storage systems, to small consumer electronic single cell applications such as wearable electronics, like a smart watches, workout trackers, and etc. So again, in a nutshell, anything that has a battery usually comes with a battery management system, but they all have different need and requirements, and they use different BMS architectures depending on those needs.
And that's interesting. I mean, you've talked about things from huge batteries in cars through to very small applications. I mean, is the underlying technology and what you're trying to do always the same, or do you look to do different things depending upon the application?
Well, the bread and butter is the same, right? When we want to really talk about functionality of any given battery management system, whether it goes in an EV or it goes into the low voltage consumer electronic, a battery management system wants to achieve two things mainly. There are two main aspects. One, monitoring of the batteries, and the other one is the balancing of the batteries. So what is a monitoring? Monitoring, basically, official definition is the continuous measurement and supervision of various parameters such as voltage, current, temperature of the battery or battery pack, and measuring and monitoring of battery SOC. You will hear SOC or SOH, these terms a lot in battery management system. And battery SOC stands for state of charge of battery. It is a key parameter used to indicate the current charge level of a given battery. And you kind of need all these monitoring information to make sure that a battery is running and operating within its safe and efficient operating range. This monitoring happens usually via different methods. There are usually three popular methods for monitoring a battery state of charge. One is voltage measurement, other one is Coulomb counting, and the other one is impedance measurement. There are all other methods as well, and each method comes with its own advantage and disadvantage. For example, in a voltage measurement method, you measure the voltage across the battery terminal and then simply correlate that to SOC value using discharge curve, which is usually in a battery data sheet. Discharge curve is usually a plot which is showing the voltage over SOC or state of charge of a battery, and this is something usually given by battery manufacturers or determined by user characterization. The other method is a Coulomb counting method, which is a very popular choice. This method basically measures the amount of charge that enters in and out of battery. And also the other method is a ohmic or impedance measurement, which in this method, you measure the internal resistance of a given battery, which changes as the battery discharge and charge. And by monitoring the changes in the internal resistance, you can estimate a state of charge of the battery. And this impedance measurement can be used to also estimate the state of health of the battery. It is also another parameter which is important to monitor and to keep an eye on to make sure that your battery is basically aging in a safe and efficient fashion. So depending on different architecture needs, you might see a BMS that utilize only one of these methods for monitoring, or some BMSs, some more complicated BMSs that require, for example, higher efficiency. They might use a mix of multiple methods to attain basically higher accuracy and reliability. And another big aspect of any battery management system is balancing, what we call balancing. Balancing is really important and is a basically process of equalizing the charges across all the cells in a battery pack. This is important because as you charge and discharge a battery module array of batteries, some of the cells tend to charge and discharge faster, and these can cause some inequilibrium across your pack, and that is not good. And obviously, that is because not all the cells are identical. There are some variation from any lithium-ion battery cell to another cell. And that variation in cell voltage charges can lead to the reduced performance and safety risk. Therefore, it is really crucial to basically charge and discharge your array of batteries in a balanced fashion. And that is what balancing means. And we usually achieve the balancing in two fashion. There's two different methods for balancing as well, similar to monitoring. Balancing come in a passive fashion, which we call passive balancing, and they also come in active fashion, which we call active balancing. And the difference is that basically the passive balancing is when there is a discrepancy between cell charges, the cell with a higher charge gets simply grounded. So its charge drop to the level of other cell. In this way, other cell can catch up with this cell and all the cells can charge in a balanced fashion. In active balancing, the cell with a higher charge, instead of just wasting the energy to the ground, it just passes the charges to lower charge cells rather than just, again, wasting it. Active balancing is a more efficient method of balancing. However, it is a lot more complicated. And as a result of that, it's not really as popular right now. So again, when it comes to the battery management system, regardless of application, there are two main important things that happen, which is a balancing and monitoring. But again, depending on different application, you can add more functionality. You can, if the security is more important, you'll add security to it. If intelligent charging and discharging is more important, you will add that to it. But pretty much all the BMSs have these two elements, which is monitoring and balancing.
That's fascinating. I mean, that covers quite a range of different functionality that the BMS has got to deliver. I'm interested, with technology moving forward and obviously a lot of, the new innovations being in battery powered equipment, what are the trends you're seeing in the battery market?
Yeah. Okay. Now we have been working on a few reference design for the last few years and engaged with a lot of customers. So there are a lot of different trends, but definitely one of the biggest trends that we are seeing is a huge need for a scalable solution where you can basically go to the higher voltages, and especially that is a big request for high voltage industrial and automotive type application. Those type of application that can go up to 800 volts, more than 1,000 volts. So we are talking about when we are stacking hundreds of lithium ion cell batteries or different chemistry. They're not real limited lithium ion, especially for industrial application. These type of architectures you usually want to have to be able to scale up or even down in the future easily. So in order to adopt or their evolving needs, for example, imagine an energy storage facility which have a huge battery storage compartment, and they want to add, for example, more capability. So they want to have a system, a battery management system that could scale up very easily. And scalability also offers different advantages, such as it offers better thermal management and better functional safety management. Therefore, again, we are seeing more customers are asking for these type of solution, modular, scalable solutions for high voltage applications. And another trend is we are seeing a lot of need for intelligent AI-based or model-based state of health determination. So as I mentioned, what we do is in a battery management system, we collect all the voltage, current, temperature information, and then we decide how we want to charge and discharge. So there is a need nowadays to basically get these and use a very intelligent algorithm to control how to charge and discharge in order to increase the battery life cycle, or in order to increase the charging time frame. So we definitely are seeing trends moving toward these directions.
That's great. There's obviously a lot happening in the market. I mean, I've also seen a lot from Microchip side, with new reference designs and announcements coming out. What's really driven Microchip to put so much focus on the battery market?
Well, as you mentioned, there is a boom in electrification. And as a result of that, we've seen a lot of requests for design collateral, reference design, app notes for variety of anything that is related to electrification, but especially battery management systems, right? And that, it could include also EV chargers and etc. But, BMS really has been booming recently. And it is just not, it is all over different market segments, from consumer electronic to EVs to even EV tools. They are called electrical vehicle takeoff and landing, basically human carrying electrical drones that are coming up nowadays, and they require battery management systems. So, and we also have seen a lot of our analog front end security product, microcontrollers, voltage references, temp sensors being designed into a variety of BMS applications. We've seen a lot of scattered design wins. So we focus in this application, and we released a few reference designs and technology demonstrators the last couple of years in order to hopefully can provide more extensive collaterals for customers who are interested in this very growing market. And they are interested to see what Microchip has for their BMS application. As a result of that, we released a low voltage 32 volts BMS reference design, and also one stackable 1,000+ voltage high voltage modular version, which we just recently released a couple of months ago.
So it's interesting. I mean, it sounds like people have been using Microchip products in battery management systems, but what you and your team are doing is actually making it a lot easier to create battery management designs. Is that right?
Exactly. I mean, probably our primary goal by working on this reference design is that to make it easier. And not only to make it easier, but to also provide a more comprehensive solution for our customer. For example, I earlier mentioned that how there's a market trend for intelligent AI-based model, state of health or state of charge determination. And, we've been engaged with a lot of customers over the past few years, and we've identified that one of their major challenges is actually obtaining a real-time accurate measurement and doing those complicated state of charge and state of health measurement on the background. And in Microchip, we are a hardware company. We provide semiconductors, silicons, boards, but we are not really a software company. We are not really a SoC algorithm company. And to address this need, for example, we have been collaborating with a company called BatGenie that offers their proprietary model-based software solution for a state of charge SoC and SOH measurement, which if you basically utilize their algorithm and their software, you can increase your battery life cycle and double it, and you can charge your batteries in 30 minutes with very, very high efficiency. And for example, this is a gap that we had in our hardware, and we are basically collaborating with this company to offer a total system solution and one-stop shop experience to our customer. So as you mentioned, we not only think about the collaterals and what we can do, but we constantly think how we can collaborate with other companies to basically make designing with Microchip and Microchip ecosystem easy.
And it's great to hear that term total system solution. I hear it, I think, in every podcast.
Yeah.
I'm interested to know because, I can certainly see you're using the microcontroller. You've mentioned a couple of other products like using some of the Microchip analog products. But are there any other Microchip products that get used in some of these battery management systems?
Yes, I mean the battery management system is such it could be very simple architecture for very simple application, for example, single cell or dual cell application, but it also could be very complicated. But regardless of application architecture, a BMS I think is made of 5 main blocks and functionalities. One is cell monitoring and balancing. As you mentioned in this block, we are using a lot of our analog front ends, a lot of voltage and current measurement IC product. For example, in both our reference design, we are utilizing our PAC 1952 power metering IC that is capable of measuring 16-bit 1 kilosample per second signals. And we're also utilizing a lot of our temp sensors and a lot of supporting products there. Another block and functionality is a controller unit. Obviously, the controller unit is the unit that handles all the communication. It handles, basically acts as a central controller area. And it is mainly made of our MCUs, microcontrollers. In our reference design, we are using our high-end 32-bit microcontroller, but you can really pick any microcontroller from portfolio. Again, depending on your application, you can pick 8-bit if it is enough, pick 16-bit, 32-bit to fit your application the best way. And the third block of functionality is the security section. Now, again, there is now a lot of the battery management system, again, depending on application, a lot of time communicate with a cloud, for example. In those type of battery management system, you definitely require security section where we can offer our, for example, TA100 and TA10 security anchor solution. These chips basically handle encryption, battery authentication, basically overlay security to your system, especially if you're interfacing with a cloud. And then the fourth block functionality, we have our power management section, where we are using wide variety of power conversion, LDOs, power management products, regulator, converters, and etc. And lastly, For high voltage battery management system, there's usually another unit called, or another block called battery disconnect unit, which is basically in charge of connecting and disconnecting your whole battery pack from the system, from external world in case of fault and emergency. And we currently don't have implemented this in our reference design, but we are going to do it down the road. And we can really cater to this section using our high voltage silicon carbide fuses here at Microchip. So as you can see, in addition to our microcontrollers, we actually have a lot of other products that can complement and basically build different sections of a given battery management system.
That's a great overview, and you've covered, quite a wide range of technologies there. I mean, one thing I'm interested about, Iman, is you did mention connectivity there. What are the trends where people are looking to actually connect their battery management system and be able to remotely monitor it?
Yes, this is really a good question because again, this is one of the trends that I perhaps maybe didn't talk about it much. But there is a huge trend actually, especially for modular and scalable battery management system. And there is a huge trend about how they are architectured basically. And there's something that is keep coming up is zonal architecture friendly battery management system or zonal architecture. You probably have heard that a lot in automotive segments nowadays. Tesla has moved towards zonal architecture. A few other car manufacturers are moving toward this direction, I believe. And these type of architecture are gaining popularity because instead of traditional vehicle architecture, which uses many separate controller units and long wiring harnesses, zonal architecture organizes electronic into geographic zones of vehicle. For example, front left, front right, rail left, and each zone handles its own local sensor communication and connects to the central computer, one central computer unit, usually via a high speed communication backbone like Ethernet. Now, this has been really desirable because this helps for, especially for automotive application, this helps with better management and reduce wiring. And this is one trend that we've been seeing, asking customers for zonal friendly battery management system, or so that's what they mean by this. And in our high voltage battery management system, we are actually have implemented zonal friendly architecture, and we are actually showcasing our highest speed 10 base T1S Ethernet products to facilitate this high speed Ethernet backbone communication needed for this type of applications. And that also, I believe I talked about the cybersecurity as well, which is, it's really big, especially if there isn't connectivity to the cloud. That is a really big thing because we've seen a lot of, especially automotive EVs that want to have ability to send basically SoC and SOH data logs to the cloud and have them stored in the cloud and do the computation maybe somewhere else. And therefore, they actually require a lot of encrypted way of communication as well, where we are trying to cater to those needs using our automotive friendly T800 solutions, basically. And actually, T800 was a very high end encrypted solution, which was kind of built to handle encryption, secure boot up, cloud communication. And our team also released the T810, which is dumbed down version of it, which basically is meant to go to the different battery modules that is going to communicate with the T800, and T800 will communicate to cloud.
That's amazing. I mean, there's so many things in a battery management system. I hadn't realized how complicated it was. I mean, Iman, how would you sum it up? I mean, what would you think the most important thing for listeners to remember about microchip and battery management systems?
I think what we're really trying to push here in Microchip is, we want to, as you probably noticed, I mean, the battery management system is really vast. area. It is something that, we are seeing thousands of different architectures for different needs, for different applications. So what we really want to do here is that we want to showcase our very flexible BMS solutions that could be targeted to different needs. And that is what we kind of did with our latest high voltage modular battery management system. Please make sure to come to our website, check that. And we'll also offering all the design files with it, rudimentary SoC and SOH firmware files. As I mentioned, we are collaborating with Bat Genie. We can maybe demo a solution with Bat Genie for your application so you can review it. And yes, so please make sure to check us out. And we also have an active application team where we can absolutely set up a meeting to get in touch with a customer and advise them how they can take our architecture and fine tune it for their specific needs. Again, we do have a wide variety of different IPs needed for battery management system. And we kind of put them all in together in a reference design, but probably that reference design needs to be fine tuned for your specific application. And we can definitely help customers to do that as well.
Thank you. I mean, it's been fascinating. One last question we always like to ask people before we let them go. Can you give some engineering advice? What would be your best engineering advice to listeners?
I think when it comes to the battery management system, again, we started, for example, working on this reference design a couple of years ago. And what we've learned is that if you really want to start from a BMS from ground up, do keep stuff such as cybersecurity and scalability in mind from the beginning, because it will make it a lot easier to set up a right foundation for those to be scaled up correctly in the future. And that's something that we had to deal with earlier on, and we had to do some revision, go back. But that is why we are actually publishing all of our work and reference design online, so customers don't do those mistakes. But again, if you're working in a system, please keep stuff such as cybersecurity, scalability, functional safety in mind from the beginning.
I mean, that's great, Iman, to see, advice and it coming from real life experience of trying to build a BMS. So, Iman, this has been an amazing episode. We've covered so much. If listeners are interested in finding out more or maybe have questions, what would be the best place to go?
First, please make sure to check our modular battery management system reference design. Go to the microchip.com, go to our search box and search for modular battery management system. It should be the first one or second one. And you have a high voltage and low voltage you can look into. And also, please feel free to reach out to me via email, which is Iman, Iman.Chalabi @microchip.com, or my LinkedIn for any question or any supports that you might need with your BMS or any comments. Thank you.
That's very kind, Iman. Thank you so much for this, and thank you for explaining why Microchip is battery management.
Thank you very much, Mike.
Thanks for listening to the Microchip Is podcast. Please follow us on your favorite podcast platform to keep learning about the many technologies, products, and people that make Microchip what it is today. Look out for our upcoming Microchip Is podcasts and our new Beyond the Microchip podcast series.